So today's our 8-3, day 2, and we have an addendum to notes that you guys all have right now. But the first part of this is prove that the graph of the equation is hyperbola and find its vertices, foci, and asymptotes. Now, you'll during the addendum also be asked to figure out which one's an ellipse, which one's a hyperbola, which one's a parabola, and be able to complete the square accordingly. But remember, there are certain properties that we're looking for, and you'll be writing the standard form and the standard vertex form equation, and based on that result, you'll be able to decide whether it's a parabola, ellipse, or hyperbola. So when we go through, just make sure we pay attention to it. First thing, organization of your squared terms. I got 9y squared. Okay, I got negative 18y. And then on the other side, I've got negative 4x squared. Not the other side, but just with the x's. And then I've got plus 24x. And I got minus 63. I'm just going to put in equals 63. Okay, with that reorganization of what we're doing. Okay, now factor out. So I'm going to factor out a 9 because I have to have the leading term a 1 with the squared term. Minus 2y plus something will be part of my completing my square. I'm going to factor out a negative 4 here. X squared. And remember, I'm factoring out a negative 4. So inside, I've got that negative 6x plus something is going to be equal to 63. Okay. I'm going to make this a little bit smaller so I can conserve my space a little bit as I'm writing huge. Okay. Now, keep in mind the process for this. I have 9 in front, and I need to find half of negative 2y. Well, half of negative 2 is 1. Well, it's a negative 1, but I'm going to square it. So plus 1 there. Are you okay with where I'm getting my plus 1? Now, please be advised, it's inside parentheses that I am multiplying 9 by. So if I distribute that 9, it's really plus 9. So I'm going to add 9 to the other side over here. I have 63 now plus 9. Any questions where I got that plus 9 from? Now, the next part, I've got negative 4x squared minus 6x, but half of 6 is 3. It's negative 3, but it's squared, so it's positive 9. But I'm not just adding 9 here. I'm adding negative 36, because I got a 36. Negative 36 I just introduced on the left. I have to introduce on the right. You okay with the 9 and the negative 36 where they came from? Okay, now I'm going to combine like terms as I go through here. So now I've got 9y minus 1 squared minus 4x minus 3 squared. And I have my 63 plus 9 is 72, but minus 36 is positive 36. And now I'm hoping that you're starting to see that this is a hyperbola. Okay, because I got a subtract sign in between. If I had a plus sign, it would be a parabola. Not a parabola, but an ellipse. And then the parabola would be a y squared term, and the other term would be, the x would be, to the first power, or an x squared term, and the y would be to the first power. So I have to pay attention to those nuances with the different equations. Now, divide by 36. Y minus 1, quantity squared, 4, divided by 4, minus x minus 3, dividing by 36, I get 9, and I get a 1. This is my standard equation of the shape that we're working with. And I'm supposed to find the vertices and foci, but the first thing I can do right now is get the center. I've got a 1, 3, so I'm at 1, 1, 2, 3, my center. My A, yeah. It wouldn't be. Oh, yeah, you're right. And thanks for catching me. I'm like, oh, where am I? Thanks. My 3, 1. Thank you for the correction on that. That'd be 3, 1 as I'm going through. But no, keep in mind the y has the 4, so that's actually my a squared. So my a here is actually 2. My b is 3 as I'm stepping through because the transverse axis is working with the 2, so that's 4 long from there. And it's with y, so I'm going to go up 2 from my vertex, down 2 from my vertex, from my center. And my b is over 3, 1, 2, 3. Oh, I still got the wrong center. Thanks, guys. Still got the wrong center. So I'm at 3, 1. I'm at 3, 1. And I'm going from a transverse. I go up 2, down 2, and I've got a 3. I've done one. It's easy. It's just easy for me to say. 3, 1. Let's try to get that in there. Up 2, down 2, and still down 2 is still going off. There we go. It doesn't even look like it's 2. It looks like it's 1.5. So I go over here 3, and I go over here 3. Okay, so I've got my box. You okay with that? And I've got my asymptotes coming through here, coming through here. And remember, they asked me to find asymptotes here, so we're going to do those in a sec. But are we okay with the vertex so far and my center, especially if I don't screw up? Yeah.
What's the purpose of drawing in like the X?
Those are my asymptotes. That's the actual, the asymptotes we're about to find. We're going to find the equation of them, but that's where they're located off that box, because that box is talking about their the slope coming up. I go up to the right 3, so that's a positive. That'll be my positive slope version, and then down to over 3. But remember, I'll have the x and y, subtracted inside with my y-intercept as well.
The slope is just A.
Or b over a.
Depending on which.
Yeah, depending on which one we're going to be working with. And so the one that takes over, in this case, it's going to be this. So we're coming through here. So I've got my y going on here, and this is my leading, so it's going to be a over b this time. If it was x leading, it would be b over a. Okay. So I'm going to look at my asymptote, excuse me. And remember, it's when I make that 0. So I got y minus 1 quantity squared over 4 equal x minus 3 quantity squared over 9. But now I got to take the square root of both sides. So I got y minus 1 over 2 is equal to x minus 3 over 3. So that kind of takes over as far as where my asymptote is going to be located for my, my graph. And now I solve for y by multiplying by 2 on both sides. So I got 2, 3, and this should be a plus or minus, and really should be plus or minus at that point. And some people ask, why did I put plus or minus there? Remember, I want y equal everything, so it's going to be plus or minus with the x. And that plus or minus is about my slope. Okay. Now, I've got x minus 3 here, and this would be acceptable right here as my formula, or I should say equation for my line. And if you hearken back, it's point slope form. From the center point, I have a slope to tell me what to do on each line. So I'm in point slope form instead of slope intercept form. I can solve for slope intercept form, but this is more descriptive as I go through for the equations that we're working with. Okay? Questions about finding the asymptote at all? Remember, I take that 1 and make it a 0, and it's looking for, solving for y at that point. Okay, now, last thing we were asked to do is find foci. And the foci is outside of the vertex from the center. It's further away from the center. So that's why we go back to c squared equal a squared plus b squared. Okay, because the c squared is the largest. The c is the furthest from the center. Okay, as we're looking at this. And I've got a and b. A is 2, b is 3, and I find that it's going to be square root of 13 is my c. And if I'm recalling right, my y is getting everything, so my transverse axis is vertical. So I'm going to go plus or minus for my foci. I'm going to go plus or minus with my y value. So I've got 3, 1 minus the square root of 13, and 3, 1 plus the square root of 13. Okay, whatever that's going to be. I don't have a calculator to pop it out, but that's the exact answer. I also have the vertex that I didn't put up, but it's going to be 3, 3, and 3, negative 1. And those are the things I was asked to find as we step through this. Are there any questions about the foci, the vertex, or anything like that? Yeah?
Yeah, how did you know the vertex?
Well, the vertex itself was my A, my 3, 1 plus A or minus A. And it was 1 plus A and 1 minus A to get those. Okay? And then my final, if I get my graph going, because it's vertical. It's a real pretty graph as I go through here to fit in with what I'm doing today. Questions regarding at all? Okay, now the addendum. The 3 questions that we have, you will be asked on the test to complete the square and decide what the shape is and to graph it. And when you're graphing, make sure if it's a parabola that you include the directrix, you include the focal width, and you include your focus. A lot of times people will just put, well, it's a parabola, I'm just going to do this. I'm looking for those other pieces too. And that's part of your grade on that problem. So make sure you recognize that you're putting all the pieces in, although it's like it wasn't necessary, to go through. I put in the asymptotes when asked, okay? It's just my habit to put them in all the time, but I'm not going to have you do asymptotes when I don't ask, but I will expect foci, A, B, and the C helps you find the foci. So make sure you're finding those things each time and actually labeling them out so it's easy to find. Are there any follow-ups with those? Okay, so the extra page that you have, pull that out. Slide that out. You guys were handed that at the beginning of class on things. Okay, so you got the 3 problems. I want you to do number 1 right off the bat. Look at what you got. It's very similar to the one we just did. And you're going to use an algebraic proof to determine which conic section each equation represents. Write the equation of the conic in its standard form. Okay, if you just write it in its standard form, that will help you determine what it is. You don't need to know right away. You might get hints as you go through. So this first part on number 1, are you okay with factoring out the 4, or organizing them, factoring out the 4, and finding half of B and squaring it? And then adding that or subtracting it from the other side depending on what you're doing. Okay, at that point, we've got 4 times x squared, or actually x plus 4, quantity squared, minus 9 y plus 4, quantity squared. And that's going to come out to be, what's it, 36 as we finish out? So I got a 36 going there. I'm at this point, I'm thinking, hey, this is hyperbola, okay? Because of the subtract, okay? So I'm looking at this, and I divide by 36 all the way across, and I've got x plus 4 squared over 3 squared, but it's 9, minus y plus 4 quantity squared over 4 equal 36. So I got myself hyperbola. That's all they asked me to do. Are you okay with that? Foss, you got a question, or is it just? Okay. Well, yeah, should be 1. Thank you. Yeah, as we go through. Okay, should be a 1. That was my mistake. Plus 8?
Y plus 8 because
Yeah.
16.
Where are we? Plus 8, 16.
Then you have 9 down.
Oh, it should be 8.
Yeah.
I don't know why I did that with 4. I was thinking of something else. So yes, it should be y plus 8. And if I can just have a trifecta of screwing up, I think that was it. Now I'm happy, to a point. Okay, other questions? Or, geez, can't believe Bloom's even doing what he's doing. Okay, the second one, organizing it again with the y squareds. Now it's really nice as we're going through, and I take this, I got y squared minus 4y and equal to negative 48. For y, 48. Okay, good, love it. Bless you. Now, when we're going through, just double check, because, factored it out, got 12, half of 12 is 36. I added my 36 times 4. That's where 144 came from. I probably popped that out there. That's my 144. I just had to add 4 in there, and I got 148 plus negative 48. So that's where I get 100 on this next one. I'm going to be dividing by 100 across, so I've got x minus 6 squared. Dividing by 100, I get 25, plus y minus 2 quantity squared. Divided by 100, I still get 100, and that equals 1 as I finish out. And this one is my ellipse as I go through. Pardon?
Confused. What's the difference in the two equations?
The plus sign, or minus sign. That's why it's subtle, and that's why it was so important for us to know the difference between them, the standard forms, because they all look alike. And then, with the ellipse and the hyperbola. The parabola is pretty obvious because it's just one of the values squared, so that's like a saving grace. But the other one, just a subtle sign change or an oops, could be the other one for your conclusion. Okay, so this one is an ellipse. Okay. And it's in standard form as we go through it. Okay, any follow-ups with it? Doing okay? Do your last one, okay? And notice the difference as you do your organization, because you can come up with your final, what it will be, but you got to finish out your standard form to finish your proof of what it is. So go ahead and give that last one a try. I'm driving up to Duluth right after school, and I was just a little bit distracted by that storm. I'm looking forward to driving in it. Are you okay with the first start? Okay, now some folks be, why did you choose to do it that way over the other ways? I don't have an x squared term, so I won't need to finish completing the square on the x terms. Okay, but remember the standard form of a parabola in this situation, I've got y minus k quantity squared is equal to 4p x minus k minus h, excuse me, as I go through. So that's where I'm steering to, okay, as I'm going. So I've got to first complete the square with the y squared, with the y values. So half of 20 is 10, squared is 100. So now I'm going to add 100 to the other side, and that comes into my plus 6, okay, which is a kind of a nice start on this. And remember, it's 4p times the quantity, x, and x has got to have that leading coefficient. It's got to be a 1 when I have it inside for that vertex form. So now I've got y minus 10 quantity squared is equal to 2 times the quantity x plus 3. Okay. And now I've got my vertex form of my parabola. You okay with the differences? Okay, parabola just has one squared term, of the x or y. The hyperbola and ellipse both have both of them. The difference between them is a plus sign or a minus sign in between the two terms after you finish completing the square. Pay attention to where they're at, and you'll be golden. Okay, and you may have the opportunity to need to complete the square, and then give me all the information, foci, vertices, and which transverse or conjugate or major, minor axis, whatever those are. So you got to know the differences. And remember, semi-major, semi-minor, I'm cutting that in half, that major axis. When that word semi comes out, you're just doing half of whatever the total value is. Any other follow-ups with these? Okay, cool. Well, that's it. That's what we got for today. You guys have a great day.